Hi everyone, in this video we're going to continue our foray into separable differential equations with a sample question from the same book that I mentioned earlier, which is Elementary Differential Equations and Boundary Value Problems by Boyce and DiPrima, 7th edition. The question looks pretty complicated. Fortunately for us it isn't as difficult as it looks, and I encourage you to give it a try yourself before you see my solution. There's also an initial condition, so we need to incorporate that as well. Let's begin by just writing it down, and it is a long one, I'll warn you. Since this is a video on separable differential equations, you can probably figure that that's the method that we'll be using. And it makes perfect sense because we can basically divide both sides by the 1 minus x squared to the 1/2, and that will give us y squared dy is equal to arc sine x over the square root of 1 minus x squared dx. While that is pretty complicated, it is still a function of just x, and that's exactly what we need to make this a separable differential equation. So the left hand side, remember we're dividing by this, so that goes away, we get y squared dy. The right hand side is a bit more complex, so it's going to be arc sine of x. Since we're dividing by this, it's going to go in the denominator. We have the square root, the 1/2 over there just means square root, and inside we have 1 minus x squared. And then of course there's the dx. We're going to keep that initial condition on the side for now. When we need it to find the value of the constant c, we'll use it, but not yet. What's the next step? Pause the video, give it a go yourself. See if you can work through all the way. Even if you don't get the initial condition, at least see if you can get until there when you've got the constant c. And then actually from there it's a pretty straightforward matter to incorporate the initial condition and get an explicit solution, like an initial value problem. Anyway, let's see the next step. So we're just going to integrate both sides. When you integrate the left side, you get the integral of y squared dy. Integrating this side, it's actually not as tricky as it looks, and there is one method in particular which makes it very simple. So if you haven't gotten it yet, keep trying, and I might give you a hint. I will give you a hint. Notice anything about, what if we wrote this as 1 over 1 minus x squared times arc sine of x? Does that make it easier for you? So just think about that. That might help you out in this. The left hand side though should be pretty easy. This will just be y cubed over 3. On the right hand side now, let's actually just take this over to the side and take a look here. So what if we let u equal arc sine of x? So this is a little u substitution that we're doing here. What is du? What's the derivative of arc sine of x with respect to x? This is just going to be equal to, well, 1 over 1 minus x squared. And that's why I said that. That's why I said right as 1 over 1 minus x squared. So this works out very nicely. Of course, there will be a dx at the end, which is perfect for us because this literally just becomes the integral of u, right? That's the arc sine of x. And then du is 1 over 1 minus x squared dx. So that's literally all that we have here, u du. When we integrate this, be a little bit careful, make sure you get it back in terms of x, because if you're given a question like this on a test and you're asked to find y, and you write y cubed over 3 equals x squared over 2, you're going to get a big fat 0 because it's in terms of x, right? It's not in terms of u. So make sure you substitute back. Over here, when you integrate it, you're going to end up getting u squared over 2. Then there's going to be a plus c. So let's add that. Remember now u squared is arc sine of x. So we have y cubed over 3 is equal to u squared. So that's just arc sine of x squared over 2. And then plus c. So the plus c is still there. We can now multiply both sides by 3. We can take this cube root, and that will give us y. Before we go ahead and do that though, let's just plug in this initial condition, just eliminate that variable right away. Arc sine, if you plug in 0, it's arc sine of 0. What's arc sine of 0? That's just 0. Square that divided by 2, you still get 0. Left hand side is also 0, so c is 0. So we can get rid of that. That makes our work quite a bit easier here. Multiply by 3. Now you have y cubed equals 3/2 arc sine of x squared, and now you can just take the cube root of that, so you get y is equal to the cube root of 3/2 arc sine of x, and make sure to square that, and that's it. That's going to be our final answer to this question. So if you tried the question and you got this, great job. If you didn't get it, try to see where you went wrong, see what mistake you made, and make sure to practice that. I'll make a few more videos covering similar concepts, similar types of questions, maybe a little harder, a little bit easier, and then make sure you keep practicing, and I'll see you in the next video.